Hey guys, so let's continue our wireless communication understanding. How it is going to be further discuss about the frequency band. So already we discussed in the previous session, we having the multiple frequency band. Basically, especially in the enterprise network, just two frequency band, that is a 2.4 gigahertz and the 5 gigahertz. And we know that already, right? In 2.4 gigahertz, we having the maximum 14 channels that can be used, and in the 5 gigahertz, right, we having the more than that, which is going to be around uh, 24 channels that is going to be used for the 5 gigahertz, right? So these are the channels which can be used for the our all communication, but we know the differences between these two channels. If I'm going to use the 2.4 gigahertz, they're having the higher coverage but low bandwidth, means speed is going to be low. If I'm going to use the 5 gigahertz, that is going to be give the higher bandwidth, higher speed, but the lower coverage, right? So this concept we already understand. So moving forward, let's understand what is the key concept about the overlapping channels, right? I discussed about that. So let me just little bit discuss more about that. So we know that in 2.4 gigahertz we having a total 14 channels. Out of these 14 channels, we can just only use the 1 and 6 and 11. These three channels can be used, right? So these are the three non-overlapping channels. Means if you're going to use this channel for the any communication, like I just show that, right? In my PC also, my wireless media is using some channels. So every router having their own channels. So if you're going to use any of the channels, these channels basically going to connect to your Wi-Fi, and let's say suppose the same channel is going to adjacent router is going to use, then there is an interference. Means if I'm sending the data, that data might be not going to connect properly, and the data is having some kind of the problem. So even if you're going to use 2.4 gigahertz, this channel must be going to be changed. So if I'm going to use the currently I'm using the 5 gigahertz, you can see. So in this 5 gigahertz, we're having total non-overlapping channel is 24, right? This known as the non-overlapping channel. So if I'm going to use out of these 24, so you can see it's connected right now in the 44 channel. Similarly, if I'm going to use a 2.4 gigahertz, so it just have a three non-overlapping channels. So might be it is going to be either one, or might be then going to be the six, or might be it is going to be 11, because out of 14, three can be non-overlapping, and right, these can be only used. If you're going to use the other channels, there is a high chance interference is going to happen. So what is a non-overlapping channel? These channels are basically can be used simultaneously without causing the interference. Means what I'm going to say, let's suppose I'm connected to the one, this is the one channel, or somebody is connected to channel 2. So if he is also sending data, he is also sending data, so they are going to be do the interference, right? They are going to be, create a problem for each other. But if I'm sending the data on the channel 1 and one is sending channel 6, they are going to be non-overlapping. So basically their signals are not going to overlap, their communication is not going to be overlap, right? So this is the key concept. Non-overlapping channel means there is no interference is going to happen between these communication. Similarly, in the 5 gigahertz, there are total 24 non-overlapping channels we have. So we having the more non-overlapping channel available in a 24 gigahertz. Means the 5 gigahertz communication. I hope you guys understand it. So in nutshell, right, the non-overlapping concept is the context. It is going to be discussed in 2.4 gigahertz frequency band, and it is going to discuss in the 5 gigahertz. In 2.4 gigahertz, we having a limited non-overlapping channel, that is just three. But in the 5 gigahertz, we having the more than that, that is a 24 channels. So you can see here, if I'm going in the PPT, so we know that this radio frequency is going to be communicate, that is always going to be travel over the air in the sine wave format, and we know that what is the frequency, how it is going to be measured, what is the cycle. So this we already know that, and this frequency unit is known as the hertz. Hertz is the like the smallest unit would just measure the any kind of the frequency signals, like which is going to be happen per second per cycle. So this is the hertz. Kilohertz, that is a higher bandwidth. Megahertz, that is a more higher. Gigahertz a more. So if you have to measure that frequency in the higher bandwidth, higher space, then you just have to going to be abbreviated in the different format, like the HZ, KHZ, and MHZ, or might be the GigZ, and the bandwidth is going to be more and more in considering like how many uh like the frequency band, like in the 1 second 1000 hertz is going to be communicated. If you're going to measure in the kilohertz, megahertz is like the more than that 1000, right? And gigahertz also. And these are the, like you can see, we having these two bands, 5 gigahertz and 2.4 gigahertz bands also available. And you can see these are the non-overlapping channels, that is a 1, 6 and 11. Because if you see this diagram, if I am going to send some data right on the channel 1, and if I am going to send the data, it is going to occupy that much space. Okay, same time if I am going to send the data on the channel 2, so see this lobe is going to be overlap. See, these lobes are going to overlap. So these are the overlapping. But if I am sending data on the channel 1 and if I am sending data on channel 6, so it is going to occupy some kind of the space of the channel 4 and 5, but it is not reaching till 1. So it is fine, means it is not interfering with the channel 1 communication. Similarly in the 11, it is not going to interfere. But if I just make the 10, 10 is going to again interfere here. So this is how it is going to be done, right? So this is a non-overlapping channel 1, 6 and 11. That is a 2.4 gigahertz, right? And if you just think about the 5 gigahertz, you having the 24 non-overlapping channel, and these are the looking like in this way. You can see 36, 40, 44, 48, 50. So you can just count it, right? They are different like the definition we have, that is going to be 24, like maximum that is going to be used as non-overlapping channels. Okay, so I hope this is going to be clear to everyone. Last but not least, which I was just struggling to explain in the previous session, I was just trying to Google it, but everything is available in the book as well. Standard, about the standard. So what is the standard? So in a standard, you can see the basic characteristics of the some IEEE standard, that is 802.11 amendment, when and what standard has been designed, or basically it is going to be introduced. So first was 802.11. You can see it was like designed or introduced for the any kind of the radio frequency communication in 1997, and this was going to operate on only 2.4 gigahertz. There was no 5 gigahertz, and bandwidth maximum you can just get 2 Mbps only. You can see. So this was the first standard which was developed by the IEEE, which is the organization globally for the any kind of the technology based standard. It is going to be defined another vendor who is just doing the manufacturing. They have to align with this technology, right? And the second one is 802.1b. This is again second like amendment was happened, and it was introduced after just 2 years of this particular first one, and that is the 1999, and it was giving the maximum bandwidth is 11 Mbps. The third one is the 11.g, that was in 2003, and it was giving up to 54 bandwidth, 54 Mbps. And you can see all three was not supporting 5 gigahertz. So bandwidth was low, coverage was high, but they were not supporting any kind of the 5 gigahertz frequency band. Then in 1999 itself, there was another standard was introduced, that is the 802.11a. This was supporting only 5 gigahertz, not supporting 2.4 gigahertz. But it was at the same time supporting the speed as a 54 Mbps. So if you have the like the requirement for 5 gigahertz in 1999 to just use a 5 gigahertz frequency, but then you have to use this standard. But in the later in 2009, high speed throughput was introduced, that was the 802.11 n. In this both case, the 2.4 and 5 gigahertz they having the availability, and it was giving up to 600 Mbps bandwidth, right? And 802.ac, you can see it was just going to operate on the 5 gigahertz. There is no 2.4 gigahertz, but it's going to be given up to 6.93 Gbps, and this is the latest one. And this is also, this is a Wi-Fi 6, that is like the huge, like we having the 4 type of the AC. So you can think about that. You just consider 7 Gbps, so it's going to be around 28 Gbps speed in that case. This is like the future of the Wi-Fi. So if you're going to use this Wi-Fi 6, this is the standard is going to be supported. But most of the company or most of the laptop you're going to find this or might be this. So if you see in the my scenario, you can find the standard as well in my scenario, which Wi-Fi standard I'm using. So you can see this is using this one, Wi-Fi 5, which is 802.11 AC. You can see. So it is going to support up to 6.93 Gbps. This is all about the standard of the Wi-Fi, right? So we concluded about the Wi-Fi radio frequency in a standard. So we'll move in the second chapter of this particular wireless, and we just have to understand about the more about the wireless architecture. Okay, so let me stop it here and we'll continue with the next chapter. Thank you.